Greetings Year 13s. Here we're looking at our second example of implicit differentiation. And so I'm going to start by writing out each term that's being differentiated. So d by dx of 2x squared y plus d by dx of 3xy squared, and that equals d by dx of 16. Okay, so here we've got a little bit of a problem because we have a term with both x and y in it. So what we have to do is differentiate it with respect to x, and then differentiate it with respect to y. With respect to x, but differentiate the y part. So first of all, differentiating it with respect to x, what we're going to do is treat y as a constant and only differentiate the x part. And so that will be 4x, and because y is a constant, it is still there. Okay, now we're going to differentiate it with the y term, still with respect to x, so we're going to treat this as a constant, and so we're going to write plus 2x squared, and because we've differentiated this y down to 1, we're going to times it by dy by dx. Okay, now we have to do the same with the next term as well. So differentiating the x part first, we're going to have 3, the x is going to differentiate away, and treating y as a constant, it remains, and then plus 6xy, and because we differentiated the y term that time, we have to times it by dy by dx. That'll equal 0 because this thing differentiates to 0. So that's the hardest part of this whole process, is working out where you're timesing dy by dx by, and I expect I'll probably get a lot of questions about this in class as well, which is fine. So now our requirement is to solve for dy by dx, and so we want to get all our dy by dx's together, so we want to subtract 4xy and 3y squared from both sides. And so that will leave us with 2x squared dy by dx plus 6xy dy by dx. And that's all going to be equal to negative 4xy minus 3y squared. So now that I've got all of my dy by dx's on one side, I can factorize them out. And so I'm going to write dy by dx and factorize them out. So I've got 2x squared plus 6xy, and that's all equal to what we've got here still. And now I can divide both sides by this bit here. And so we can say that dy by dx is going to be all of that right hand side divided by all of this, and that's it. So quite a complex derivative in the end, but the key really is to know what you're differentiating with respect to, and that whenever you're differentiating y, you times it by dy by dx, and when you're differentiating a term with respect to x, but you're differentiating the y term, you need to treat the other variable as a constant. And that's the key. Okay, really there's no substitute for practice, so jump in and see how you go. And we're going to do 18.04, and hopefully that will help you get an idea of what we're doing.